Now let's reverse the process just a little bit. This time I want to write the equation of a hyperbola, but I know some different parts to it. Now again, like I've said several times, I'm more visual and I would like to see these things on a graph so I can start interpreting really what that means about my hyperbola. So I'm going to draw my points. So vertices at 0, 2, and 4, 2. Okay, now if these are my two vertices and they're lined up horizontally, that tells me my whole hyperbola is horizontal, right? And if the hyperbola is horizontal, then that tells me that x is coming first because it's all about what's coming first. So I can go ahead and fill in the basics of my equation, putting x first and y second. Let's see if we can go ahead and find the center. The center should be the point directly between my two vertices. So if I look at that, that would be the point 2, 2. So I can plug in my 2 and 2 for x and y. And now that I've placed the center, I can see what A is. Because remember, A is the distance from the center to a vertex. So if my center is at 2, 2, and I've got a vertex at 4, 2, that means that A must be 2. So we can go ahead and put that first as our a squared. Again, remember, in a hyperbola, a squared is always first as opposed to biggest. I don't know how it compares to b right now. Now, the next thing I need to think about are the asymptotes. Now, remember, the asymptotes always go through the center, and I can see that because I've got the x minus 2 and y minus 2, just like my two numerators. And my asymptotes have the slope that help me represent the denominators. So that slope, that root 7 over 2, is representing the square root of the y denominator, which in this case would be b. So I'm going to change that out. Let's make that b, over the square root of the x denominator, or a. Now, if we know that a is 2, hey, look, that matches up. That tells me that b must be the square root of 7, right? Because it's in that ratio. So if b is the square root of 7, all I need to do is square that, and I'll have my second denominator of b squared. So if b is square root 7, I square that and I get 7 as my second denominator. Okay, so I can say b is bigger than a. That's okay, doesn't matter. A comes first. I've got the center of 2, 2, and I've got x first because I knew my hyperbola was opening sideways. All right, I'm going to switch to a little skinnier pen for our last problem. So just like with all the other conics with circles and ellipses, we are going to take an equation in what's called general form, and we're going to rewrite it in standard form. And you'll see the process is very, very similar. We've done this with circles. We've done this with ellipses. Let's just continue it for hyperbolas. All right, so with this equation, I want to rearrange it. So I want x's and y's grouped together. Now it's a little different here because I would like to keep the positive squareds first because we're going to have a positive squared term and a negative squared term because of the minus that's built into our equation. So in this case, I'm actually going to put my y's first because they're positive. So 4y squared looks like I have a plus 16y. Now I'm ready for my x's. So minus 9x squared minus 54x. And just like always, I'm going to go ahead and take that 101 and add it to the other side. Okay, so I've rearranged. Y's are coming first because they had the positive squared coefficient. And now, just like with ellipses, anytime we have a coefficient in front of our squared term, we need to factor it out. So for the y's, I'm going to factor out a 4, which leaves me y squared plus 4y, and I'm going to leave myself a little space because you know what's coming. Now for the x's, I'm going to factor out a negative 9. So minus 9, which leaves me x squared. Now be careful here. It was a minus 54x. I'm factoring out a negative 9. That changed the sign inside to a plus 6x equals 101. Okay, so that's something to watch out for. You're going to probably have to change that second sign because of what you're factoring out. All right, let's complete our squares. For the y's, we're going to take half of the 4 and square it, which is a 4. But remember, we did not just add 4 to the equation. We just added 16. So I need to put a plus 16 on the right side. Same with the x's. Half of 6 squared is 9. But again, that isn't really a 9. It's a minus 81 because of the negative 9 hanging in the front. So minus 81. And now we can just clean it up like normal. The y squared plus 4y plus 4 factors into y plus 2 squared. minus 9, then I'll do what, an x plus 3 squared. And now I've got to think for the right side. 101 plus 16 is 117. And then minus 81, I'm actually going to grab a calculator real quick. 117 minus 81 gives me 36. So equals 36. Okay, so again, same process as the ellipses. We just have to keep an eye out for that negative as we factor it out. And then just like with ellipses, we need this thing to equal 1. So I'm going to divide everything here by that 36 so that my constant equals 1. So the 4/36 will make it y plus 2 squared over 9. The 9/36 will reduce to a fourth. So x plus 3 squared over 4. And then I've got my 1. Okay, so now this looks like the equation of a hyperbola. So let's go ahead and find all these pieces to it. So starting with our center. Center on the top looks like it's a -3 for x and a -2 for y. Remember in hyperbola, a squared is first. So if a squared equals 9, then a equals 3. And my vertices are going to be following the y direction because y came first. So from the center, if we move 3 up, we would get -3, 1. 3 down from the center would be -3, -5. Foci, let's go ahead and find c. So c squared equals a squared plus b squared. So I'm adding my denominators together, which is 13. So c is going to be the square root of 13. And again, I'm following that y direction. So my foci will be -3 and then -2 plus or minus square root 13. So that c has just gone with the y value to move the foci up and down. And then the last thing let's do is write the equations of our asymptotes. So y minus k, y plus 2. So there's my y numerator equals, I'm going to skip my slope for just a sec, and then my x numerator is x plus 3. Okay, so the slope, rise over run, would be the square root of the y denominator over the x denominator. So it looks like it's just going to be 3 over 2. So I'm going to make it a plus or minus 3 over 2. Okay, so we have all our pieces, and now all we have to do is graph. So center at -3, -2. Vertices were 3 up from there and 3 down from there. 1, 2, 3. Foci were from the center, the square root of 13 up, and that's what, almost 4? So 1, 2, 3, almost 4. 1, 2, 3, almost 4. Those foci should always be located farther out than the vertices should be because the foci are inside those branches. Okay, let's go ahead and plot the asymptotes. So I know it's going from the center. Now I just need a slope of 3 over 2. So I'm going to go up 3 and right 2, down 3 and left 2. That would give me 1 asymptote. And then up 3, left 2, down 3, right 2. And again, there's kind of that rectangle. If you want to create the rectangle using your slopes or using your A and B. There's that asymptote. And now I can see this is just a little skinnier as it stays within the asymptotes. Okay, so the process again is very similar to that of the ellipse. We just have to keep an eye out for that negative. As you factor out that -9, change the sign. Okay, and then again, for your asymptotes, square root of y denominator is your rise, square root of x denominator is your run.